Thanks for watching another installment of Eye Tracking Fundamentals from Argus Science. In this episode, we will be discussing saccade detection using the ETVision and ETAnalysis package. Saccades are rapid ballistic movements of the eye, normally found between fixations. To identify saccades, we must be able to distinguish them from other eye movements including smooth pursuit and eye movements used to compensate for head movements. We first identify fixations and then examine the periods between fixations to identify saccades. In addition to a minimum initial velocity, saccades are characterized by a typical range of relationships between amplitude, duration, and peak velocity, and we identify and filter based on these relations. Once saccades are identified, we report a list of saccades, each with a start and end time, and a list of metrics, including amplitude, the size of a saccade measured in degrees of visual angle, duration, the time in seconds from onset to conclusion of the saccade, average velocity, the amplitude of a saccade divided by its duration reported in degrees per second, peak velocity, the highest eye movement velocity reached during a saccade reported in degrees per second, and direction, the average direction from start to end position reported as horizontal and vertical components of a unit vector. After collecting a participant's gaze data at 180 Hz using the ETVision, we can launch ETAnalysis. Creating a new project, we can name the project and choose any options used during the collection session. We can now load a data file into the ETAnalysis project. We may choose to review the gaze data, and we can now calculate fixations for this data set and review the fixation data. Now we can calculate saccades from the fixation file. We will view a saccade dialog. Some of the detection criteria can be adjusted by the user, or the default values may be used. A saccade node is created, and we can view or export the key metrics of each saccade, including peak time, amplitude, average velocity, peak velocity, direction vectors, and start and stop times. We can visualize this data by creating a time plot from the saccade node. In this example, we will choose the horizontal gaze and vertical gaze points from our available data fields. We will set the data range from 0 to 1280 for both selections. We can see the time plot and zoom in to see the blue lines showing the fixation periods, the yellow lines showing saccade periods, and red indicating the actual gaze data points. Moving through the time plot, we can view the fixations and saccades throughout the collection. We can also view the parameters used to create the saccades, as well as a brief summary showing event duration and total number of detected saccades. To learn more, visit our website. If you have specific questions, feel free to contact us through our contact feature. Thanks for watching.